Hi, this is Dr. O'Connor. Welcome to Pathways to Chemistry. Well, let's take a look at this problem. We have a sample of dry air, and we're told that it occupies a volume of 93 liters. If the sample is cooled from 145 degrees Celsius to a negative 22 degrees Celsius, and we're also told that the pressure is maintained at 2.85 atmospheres, what is the final volume? Well, sometimes students have a difficult time trying to decipher when they use the combined gas law or the ideal gas law. The combined gas law is used when there is a change involved. It tells us here the sample is being cooled from 145 degrees to negative 22 degrees Celsius. So in this case here, we're going to use the combined gas law. And let me go ahead and write that for you. Over T1 equals, over T2. So remember, these are initial conditions and these are final conditions. And we're going to assume that N is constant. And remember, N is the number of moles. Okay? So let's go ahead and write down our variables here. Here we're told the pressure is maintained at 2.85 atmospheres. So the pressure is constant. Okay, so this does not enter in. So if we have a constant pressure and a constant amount of gas, that means that here we're dealing with Charles's law. Okay, so Charles's law, what does that state? You have your volume being directly proportional to the temperature. Okay, so let's go ahead and define everything. So our initial volume is 93 liters, and our initial temperature is 145 degrees Celsius. Now we have to convert this to Kelvin. So when we convert to Kelvin, we have 145 degrees Celsius plus 273.15, and that is going to give us 418 Kelvin. And let's see, we have our T2, our final temperature, is a negative 22 degrees Celsius. And in Kelvin, it's going to be a negative 22 degrees Celsius plus 273.15. And that is going to give us 251 Kelvin. Okay, so now we're ready to go. All right, now remember, because our pressure is held constant, the pressure terms cancel out, and we're just left with this expression here. Okay, so let's go ahead and solve for V2. That's what we're looking for. We have V1, we have T1, we have T2. So what we're looking for is V2. So let's go ahead and solve this. So with a little rearrangement, we end up with V2, our final volume, equal to the initial volume times the final temperature over the initial temperature. So now all I have to do then is put in my values. So V2, let's see, volume 1 is 93 liters. I multiply that by the final temperature, which is T2, and that is 251 Kelvin. Then I divide that by the initial temperature, which is 418 Kelvin. And let's see what we get here. Do notice that your units cancel. It's always a good idea to write your units in, because that way, if your units are not canceling like they should, there's something wrong with the setup. So let me see here. This is equal to 56 liters. And that makes sense, right? Because we know that when the temperature is decreased, then my volume is going to decrease as well, according to Charles's law.